This video is to help you understand what an nth root is. We're probably familiar with the idea of a square root. Remember, a square root is basically a number underneath a radical. The radical is that sort of check mark sign that's going to contain your radicand, the number underneath. The index is the number that goes sort of inside of the check mark. Now, a square root normally doesn't have a number there at all, which is why we know that it's a square root. So knowing that 4 squared is 16, remember, a basic idea of a square root is to tell us that the square root of 4 times 4, or the square root of 4 squared, square roots cancel squareds, so the square root of 16 would be 4. Well, there are other kinds of roots. Square roots are just sort of one of the smaller types. A fourth root cancels a fourth power. So just as we know that 3 to the fourth is 81, well, the fourth root of 81 is essentially the fourth root of 3 to the fourth, and this index cancels the exponent because the fourth root and the fourth power are inverses of one another. They're going to cancel away, and that base will be your answer. So if 2 to the fifth equals 32, then the fifth root of 32 can be rewritten as the fifth root of 2 to the fifth, 32 and 2 to the fifth being the same thing, and your answer then is 2. The fifth root of 32 is 2. So you may see problems similar to this. Again, sometimes it's hard to go from words to problem, but once the problem is set up, it should be fairly easy. Find the indicated real nth root of A. Again, to be an nth root, that tells us that 4 is going to be our index. So we're going to find the fourth root of, and we're saying of A, so 10,000 is what's going to go inside of our root. From there, we just need to figure out what to the fourth power would be 10,000. Well, 10 to the fourth is 10,000. So the fourth root of 10 to the fourth is just 10, and that's our answer. Now, one of the tricky things about having roots other than square roots is to remember that, well, you can't take the square root of a negative number. And that same rule applies as long as the index is negative, is even. The radicand must be positive in order to take an even root, such as the fourth root of 16, again, we saw that on the previous page, comes out to 2. The fourth root of negative 16 is saying that we need a number that multiplied within there 4 times. So such as negative 2 times negative 2 times another negative 2 times negative 2, or essentially 4 negative 2's all multiplied together. The problem is, if you multiply a negative number an even number of times, the number underneath wouldn't have stayed negative. Right? 2 to the fourth would be 16, but realize that negative 2 to the fourth is also 16. So the fourth root of negative 16 can't be a real number. The negatives won't line up correctly. However, with a cubed root, realize that 5 cubed is 125. So the cubed root of 125 is 5. At the same time, negative 5, the quantity cubed, is negative 125 because there's an odd number of negatives in there. The third root of negative 125 is still negative 5. So you can still find an answer there. Now, one thing to keep in mind is we don't want to start throwing plus or minuses around either. It's another thing to be careful of with roots. Remember, when we solved even root problems, such as square roots, we would say plus or minus. It's because when we're saying that x to the fourth equals 16, we're saying what are all the possible x's that to the fourth power could give you 16. Well, remember, 2 to the fourth is 16, but negative 2 to the fourth is also 16. So when we take the fourth root in order to cancel the fourth power, we also have to say plus or minus. However, if you're finding a principal root, if you're not solving an equation, you're just answering the question saying, what is the principal fourth root of 16? The answer is 2. What is the negative fourth root of 16? Well, the negative outside the root means I can still find my root. Fourth root of 16 is 2. Negative in front of it would be negative 2. However, those are two separate answers, unlike solving the equation that just happens to have two solutions rather than one. principal root is just finding a root. Solving an equation, remember, you're finding all possibilities, not just the first one. Last thing we're going to do in this video is just to explain again a little bit more about what makes it real or not real when you're finding a root. Realize that again, 3 squared and negative 3 squared both come out to 9. 3 to the 4th and negative 3 to the 4th both come out to 81. Therefore, when we're thinking backwards, the 4th root of 9 is going to be a real number. Or sorry, the square root of 9 is going to be a real number. But the square root of negative 9, remember when something is squared, it'll never end up negative. So the square root of a negative will never end up real. These, remember, would have come out to 3 and 3i from our previous sections. Not a real number. Now, when we're talking larger roots, such as 4th roots, remember that anything to the 4th also comes up positive, so the 4th root of 81 also would have come out to 3. However, the 4th root of negative 81 just comes up as a non-real number. Okay. We're not going to say that's equal to something with I, we'll just say it's non-real. Now remember, with a third root, 3 to the third is 27, but negative 3 to the third is negative 27. So both the cubed root of 27, also being equal to 3, and the cubed root of negative 27, being equal to negative 3, they're both real numbers. So for a 5th root, again an odd root of a negative number, it'll still come up as a real number. And if you double check, 3 to the 5th is 243. So the 5th root of negative 243, such as down here, the 5th root on this side would cancel the 5th power over here on the left, and negative 3 is equal to the 5th root of negative 243. Biggest things to remember is if you have an even root, you must have a positive number underneath in order to get a real answer. Odd roots will always have real answers. Hope that helps you with your roots, and good luck on your assignment.